Hey everyone, welcome back to another YouTube video showcasing the PicoCTF 2022 Capture the Flag. In the last video, we got through a buffer overflow challenge. It was the first binary exploitation where we're really taking advantage of the instruction pointer for a program. It was super cool, it was crazy long, but we got a whole lot of learning in there. And if you haven't checked out that video, please do. And this video, we're moving on to something new, doing some cryptography this time around. All right, so I'm gonna hop over to my computer screen. I do, of course, have my terminal open, and I have a new challenge in front of me in the cryptography category called Diffie-Helman. This has a bit more solves than the previous challenge, but they said, hey, Alice and Bob wanted to exchange information secretly. The two of them agreed to use the Diffie-Helman Key Exchange algorithm using P equals 13 and G equals 5. They both chose numbers secretly, where Alice chose 7 and Bob chose 3. Then, Alice sent Bob some encoded text with both letters and digits using the generated keys as the shift amount for a Caesar cipher over the alphabet and the decimal digits. Can you figure out the contents of the message? Download the message here. That's weird and wild. Okay, let's go ahead and grab it, and then we can wrap the decrypted message in the PicoCTF flag format. Let's go ahead and move into the cryptography category, make a directory for Diffie-Helman, and download that file with wget. Okay, I'll open it up in a text editor, and I have this thing. So let me reread this. They sent encoded text with both letters and digits using the generated key as the shift amount for a Caesar cipher over the alphabet and the decimal digits. Okay, so we need to determine the key that was chosen or returned from Diffie-Helman. Now, Diffie-Hellman, if you aren't familiar, is exactly how it explained a key exchange. It is a method of securely exchanging cryptographic keys over a public channel, as one was was one of the first public key protocols put in place in 1976. Goodness. So the Wikipedia page kind of breaks down how this all happens. We knew that there were a whole lot of values flying in there, P and G, and the keys are the individual numbers that Alice and Bob, were those the casting characters? Yeah, Alice and Bob, and what they were chosen as their numbers. Let's go and explore how this is put together with that general overview. They choose some values, a cryptographic explanation. They publicly agree to use modulus P equals 3, or excuse me, 23 in this case, and base G equals 5, which is a primitive root modulo 23. Alice chooses a secret integer A and sends Bob capital A, which is G raised to the A mod P, and you could determine what that value is. Bob chooses a secret integer and then sends Alice capital B, which is G raised to that mod P, and they determine, based off of some computation, capital B raised to her chosen A mod P. And that is actually something that they actually could both uncover based off of these values given S. They now know the secret number, or in that case, the key. So we just kind of have to do some exponents, do we not? Let's put the puzzle pieces together here. I'm going to go ahead and create a Python script to play with this. I guess I'll call it like get flag. Nah, we'll just call it diffie.py, because I don't know if we are going to end up cruising with the flag into this thing. Let's go ahead and use a shebang line. And we know a couple things here. P is 13 and G is 5. Yeah. So Alice chose 7 and B is 3. Good enough. And based off of what they're doing in this Wikipedia page, they determine a capital A, which is sent to Bob from Alice. We're using a G raised to the power of A, all mod P. Right? And B, which Bob determines, is G raised to B mod P. So we could probably print out A and B and actually even check if A is equal to B, because it theoretically should be, right? Let's hop back over to the terminal and try and run this code. Verify that it is getting us a number. It's the value of 8. Yeah? Okay, and that is determined to be true. And that A and B are, yes, they're both 8. That is the secret that was uncovered by this Diffie-Helman Key Exchange. That is, in fact, the key. Right? Well, no. They do some shenanigans here. They determine S. S should be the same. Did I have that methodology wrong? They choose S to be the power of B raised to A mod P. And I guess that can be S for Alice, S of A. And then we could do S of B, in which case they had capital A raised to B mod P. Keep in mind, hey, first argument to power is the base here. Second argument is the exponent, and third argument is the modulus for that. So let's do that quick print one more time with SA, and we'll do this on different lines here. And let's actually use an F string to showcase these values. If you add an equal sign at the very, very end of the curly braces that you use for a Python F string, it will tell you and show you, hey, this is the variable that you wanted to actually display, as well as the actual value. So that might be kind of neat. Let's see that in action. S of A equals 5, S of B equals 5, and if these values are equal to each other, that is in fact true. So S is now determined, and that is the key that we used. So with that said, we have this thing that is allegedly a Caesar cipher shifted by 5. So could we use some of the tools that we had known previously, like Caesar, right? We were able to install that from the BSD games module, or that package, and we know 5 is the key that we just determined. That might send it in a different direction, though, because whether it's rotating and shifting to the right or to the left could kind of vary. So if we were to do 26, the number of letters in the alphabet, right, minus 5, going in the opposite direction, that's 21. And that looks a little bit better. Caesar cipher. Does it? Does that look better? I'm not quite sure. Should we have done 25? Let's do 22. No, none of those seem to be exactly right. Or is it because of the decimal digits that are doing weird things? Let's try it wrapped inside as the flag. I totally grabbed the wrong one. Let's try and use this guy. Nope, still wrong. Okay. I don't have the Diffie-Helman Key Exchange wrong, do I? Maybe we could just use this original thing and find a different and better Caesar cipher with numbers, because it is shifting them. It's suggested that, I think. Knowing the shift of 5, let's try and decrypt that. No. That's giving me the same. Unless, for whatever reason, this was... the previous rendition was the right direction. No. Using the generated key as a shift amount for a Caesar cipher over the alphabet and the decimal digits. Can you figure out the contents of the message? So we would rotate numbers as well, though. Does Planet Calc have a better tool? I think that says it does include the numbers here. So let's get the original string, slap it in, and calculate. Rot 5. That's one direction, but we know that the other direction is more likely. No. I think that is right, though, to consider the numbers being moved and shifted just as well. Because what we're seeing here, if this were a 3, and if this were an 4 or something, because C, oh no, it would be 4 and then 3. C ver cipher, maybe this becomes a 1. That becomes a 3. That should work. Caesar cipher would be spelt better in leet speak there. But the V is still wrong. Some of those seem wrong. Is it trying to say Caesar cipher is a... I don't know. I'm not... I want to look at the hints here. I want to see what the heck... Because I feel like I understand this, and I don't know why it's not coming together. Yep, I understand how the Diffie-Helman Key Exchange. Try forwards and backwards. I've done that. But I need the numbers in there just as well. If I add the alphabet with numbers, does that work for some reason? No. Let's see if Crypty or any of these happen to do it the right way. I don't have any shame. Let's do 5. In which case 21. Still wrong. So that adding the alphabet is not going to do it properly. It needs to take the numbers shifted as well. Oh, that went in a different direction. None of these are going to end up doing it. Yeah, that didn't even keep track of the numbers. That just threw them out and the underscores. That's silly. 5, encrypt and decrypt. Let's use 21. Still does not keep the numbers, it looks like. No. All right, well, fine. Let's write the code for it. Open up a text editor. Let's use Python 3. And we could do some horrible things together. Let's import string to get the digits as well as the ASCII uppercase letters. And what we could do is actually import something else called collections. Collections is kind of weird because collections has a file type called a DQ or a deq. I'm bad at everything and pronunciation especially. So if I were to use string.ascii uppercase and consider that a shifter, let me show you what that puts together for us. I'll disable build view yet again so I can run this. And does that have a problem? Collection is not defined. Yeah, that should be collections. Sorry. There we go. So this gives us all of these letters put together in a DEQ and actually does an interesting thing because we could say, hey, I want to take this and I want to literally rotate it by 5 as what we know. And should it actually be 21? I suppose we could play with that. But if we actually made this back to a list and then joined this together, we could have a new shifted alphabet. So let's try that. Let's say shifted uppercase set to this thing. And let's do the very, very same for, let's call this add a shift value function because we know it could either be 5 or 21 depending on the direction that our code goes in. Let's set that rather than hard coding the value in there. And let's also supply this for the numbers and the digits just as well. We'll say shifted digits. So now we have both the shifted digits and the shifted alphabet as something that we can work with as if we wanted to go ahead and rotate values for us. working through the original message.txt string. Yeah? Does that kind of make sense? So what we'll do is we'll go ahead and open up the message.txt file as a file pointer, file handle, whatever you want to call it. We'll go ahead and read the contents out, store that, and we'll loop through for every single character in the contents here. We can check if the character is in the original string ASCII uppercase English alphabet, then we want to grab its position and its index and use that as, again, to kind of reference what it might be in the shifted alphabet. So let's build out the flag as in a string as we usually do. We'll get the position to be string.ASCII uppercase position of the character, or sorry, that's index is the function that I want to run for that. And with that, we could actually add to the flag using this mapping based off the index. We could actually get the shifted uppercase rendition of that indexed at that position. And I might have these backwards in all reality, but because it is just a shift one way or the other, again, it'll rotate and flip depending on the shift value that we use. So I don't think that'll be too bad. We'll also have the elif in case it is a digit. And we'll basically write our own code for this custom, quote-unquote, custom Caesar cipher that handles numbers as well as digits. So we'll check if character is in string.ASCII or digits. We'll grab it and use the shifted digits position. Otherwise, like in case it is an underscore, which we know we do have in the message, we can just add the underscore in there. We aren't going to do anything else with that. So we'll go ahead and just append the character. Now, ultimately, at the very, very end, we'll join that flagged list all together. And theoretically, in case I got anything wrong, which it looks like I did, it's just whining about spaces and tabs again. I'll use Control-Shift-P in Sublime Text to convert those to spaces. Run that. That looks a little bit better. Caesar cipher is a Yix OX A day. It looks like, it seems like it got so close, but it's still wrong. Oh. Outdated heyday? What is that supposed to be? Caesar cipher is an outdated something? Let's submit that flag, I guess. No. Why is this weird? It's just 21. Caesar cipher. I feel like I have to guess. So V is a bit outdated. Oh, and that must be my hexadecimal value at the end there. Did I do something wrong? Caesar cipher is a bit outdated and my hexadecimal value is at the... What? No, it's still wrong? Does it need to be like a Z? What? So this challenge, let me say, has 25% liked. It was seriously thumbs down, and 9% of correct attempts. So I have a feeling something might be wrong, unless I could be doing something bad here. I'm rereading this challenge prompt over and over again. What did we have? We had it as this. And we said that V is an S. A Y is a B. And X is a T. Are our A's correct? I don't trust any bit of this anymore. I honestly don't. Let me just mess with this for a little bit and see if I can get it. Because no, it doesn't need to be lowercase, does it? Ooh. F minus 5 is going to go to A. All the other tools got Y's at the end, did they not? Yeah. I'm sorry, everybody. I am like in genuine disbelief at what the heck is going on here. The B was a D, and that's what we ended up choosing, but the 3s could also very well have been. That is not minus 5. That's why it had a Y there. Because it wrapped around the wrong, different way. But if you added 5, A, B, C, D, E, F, G, H, I, that doesn't work either. C, Zer. How did the A become a... I feel like I have to ask, like, on their Discord. Do they have a Discord? I'm in their internal dev one. Event info. Full event rules. Oh, Discord. Let me in. Oh, come on. Yeah. Join a server, please. Okay. PicoCTF 2022. Category discussion. I want 2022. Search for Diffie-Helman. For the love of God. Who are you? Who are you, Zerotistic? What do you know? Kiss my axe? Hydra? Tell me what you thought. Diffie. I love how easy it is to brute Diffie-Helman. Is the Diffie-Helman flag correct? Diffie-Helman. Read the description carefully again. That's what helped me. You're too confident with your flag right now. Well, I'm glad I'm just a noob like everyone else, apparently, not being able to figure out what the heck it's meaning here. Alice sent Bob some encoded text with both letters and digits using the generated key as the shift amount for a Caesar cipher over the alphabet and the decimal digits, which is what I did. Here's what we'll do. For shift value in range of 26, ladies and gentlemen, let's just print these all out and see what we get. Caesar cipher is outdated. None of these get the word bit. You know, part of me wonders if we should just have the original be string.ascii uppercase plus string.digits so that the shifted piece will actually be the original alphabet joined and then it's not doing a check of whether or not it's in any of these. It's checking if a character is in those put together. I wonder if that's how it's all being screwed over. That's it. Okay. Oh my lord. I was trying to decouple the digits and the letters, and I finally, after carving through a little bit, banging my head against the wall for way too long, I realized, okay, if we aren't decoupling them and we are putting them together, a list of both the uppercase letters and the digits, and then shifting across all of those as if they are one string rather than two, and then being able to determine it, that looks a heck of a lot better. So we'll now have the answer PicoCTF just like this. Caesar cipher is a bit outdated. And we don't need to now be using a whole range. We can just use the proper shift value and print all this out to get our shifted original, which I just clobbered. Yeah. It was that portion. So we want to print out PicoCTF %s and just like that. And that is how we end up getting the flag here. Okay. That was awful and I hate myself, but I am going to run that and save that and finish that challenge and go ahead and submit that flag. I'm really not happy about that. That was kind of stupid and dumb, but I guess it was just me misunderstanding how we are going to end up representing, sure, the digits as well as the alphabet being Caesar cipher shifted. When I tried to Caesar cipher shift them separately, not as if they were all in their own string, it muffed it up, as we saw. When I put them together, A through Z as well as 0 through 9, then it worked and we got the proper flag. Felt like I was scraping the bottom of the barrel for that one, though, and I'm glad to see in the Discord maybe I'm not the only idiot that was doing that same thing. But I hope you learned something, and maybe you learned, hey, a little bit of that grit and that stubbornness, and like, man, why doesn't this work? Why doesn't it make sense? Anyway, hope you enjoyed, everyone. I'll see you in the next video. I love you. Take care.